Hi students, and welcome to your next math video. Today we are in Chapter 10, Lesson 7, Multiplying Mixed Numbers. Students will be able to multiply fractions, and students will be able to multiply mixed numbers. We are working from our books for this video. We are on page 747, and we've done a few of these examples in class together. So I'm going to start up here at number 4, taking 3 3/5 times 1/4. So when we have mixed numbers and we're multiplying them, we need to change the mixed numbers into fractions. And they would be improper fractions since they're worth more than a whole. So first, I need to make 3 3/5 into a fraction. And you can do this several ways. You can use manipulatives and build 3 3/5. You could draw a model for 3 3/5, or you could do the steps by themselves. So I am going to show a model, and then I'll show you the steps. 3 3/5 looks like 3 wholes. And I'm going to split each of these into 5 equal parts, since that's my denominator. And I want to shade in all 3 holes. So I needed 3 holes. There's 1 hole, 2 holes, and 3 holes. But I also have an extra 3/5. So I'm going to make another model, cut into 5 equal pieces, and I need to shade in 3 of those fifths. 1, 2, 3. So now I have a model showing 3 holes and 3/5. In order to represent that as a fraction, it will be an improper fraction, I need to count all of those fifths pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then 16, 17, 18. So I end up having 18 of those fifths pieces. And that's how we can use a model to go from a mixed number to an improper fraction. What if you didn't want to draw the model? Then there are a couple of steps we need to take. The first step is multiplying our denominator by our whole number. And that comes from the fact that we have 3 whole models, and there are 5 sections in each. Of course, 3 times 5, or 5 times 3, equals 15. So in these 3 wholes, there are 15 sections. And then we had another 3 pieces to add to that. So I take these 3 pieces and I'm adding them to my 15. And 15 plus 3 gives me 18. We always would keep the same denominator because these are all in fifths. Okay, so now that I have my mixed number written as a fraction, I can go ahead and finish my problem by multiplying. So I have 18 fifths times 1/4. I can multiply in 2 ways. I can go straight across, or I can check my diagonals to simplify. I'll show you both ways. If I multiply by going straight across, I can take 18 times 1, which is 18, and then 5 times 4, which is 20. So I get 18/20. My last step in this problem would be to check to simplify. Can I simplify 18/20? Are they in a times table together? They are. 18 and 20 are both in our 2 times tables, which means I can divide by 2. 2 is the greatest common factor of 18 and 20. 18 divided by 2 equals 9, and 20 divided by 2 equals 10. And 9/10 is the simplest form. So 3 3/5 times 1/4 equals 9/10. If I chose to simplify my problem, I would check my diagonals. This diagonal of 1 and 5 cannot be simplified. However, 18 and 4 can get simplified because 18 and 4 are both divisible by 2. So if I simplify my problem, I may not have to simplify the answer. Let's see, 18 divided by 2 equals 9. 4 divided by 2 equals 2. So I have 9/5 times 1/2. And that will give me 9/10. Same thing I got the other way. So let's recap. Let's go over these steps. Step 1 is to write your mixed number as an improper fraction. Step 2 is to either multiply or simplify. You can multiply first and then simplify, or switch it and simplify first and then multiply. And then step 3 would be the other, multiply or simplify. But the main point here is that you must turn your mixed number into an improper fraction. Let's do another one. So we did number 4. We've done the other ones in class. Let's take a look at number 5. 2 and 1/2 times 4 and 1/5. 2 and 1/2 times 4 and 1/5. If I estimated this, I can round both of these. 2 and 1/2 is close to either 2 or 3. I usually round up. And 4 and 1/5 is close to 4. So I'm getting an estimate of 12, meaning that my answer should be somewhere around 12. Step 1, turn these mixed numbers into improper fractions. Again, you could make a model or you could follow the steps. For 2 and 1/2, if I model that, I'm cutting my models into halves, and I need to shade 2 holes and then 1/2 of another. 2 and 1/2. And then I want to count my pieces. 1, 2, 3, 4, 5. I have 5 halves. Okay? So 2 and 1/2 is the same thing as 5 halves. I just scribbled out the 3 so you didn't get confused. Okay? All right, now let's model 4 and 1/5. I'll do that down here. I need 4 holes and then 1/5 of another. Cutting these each into fifths. I need to shade in 4 holes. 1, 2, 3, 4, and 1/5 of another. And count my pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, plus 1 more, 21. So I have 21 of those fifths pieces. Now, without the models, if I just wanted to follow my steps, for the first mixed number, I would take 2 times 2, which equals 4, add 1 more, which gives me 5, keep the denominator. Over here, 5 times 4 equals 20, plus 1 equals 21, keep the denominator. Ooh, I see something I like on this problem. I'm going to simplify my problem first because I found in my diagonals the same number. When you have the same number in a diagonal, they can both reduce to a 1, and that makes things a lot easier. So it's 1 over 2 times 21 over 1. And then I can multiply across. So I'm just going to rewrite that. 1 times 21 equals 21. 2 times 1 equals 2. It's a lot better than having to find 21 times 5. So my last step now is to simplify 21 over 2, which is really 21 divided by 2. Let's do the division. 2 comes out of 2 once. 1 times 2 equals 2. Bring down my 1. 2 comes out of 1 0 times. 0 times 2 is 0. I have 1 left over out of the 2. I get 10 and 1/2. So 2 and 1/2 times 4 and 1/5 equals 10 and 1/2. And that is close to my estimate of 12. Let's recap our steps. I turned both mixed numbers into improper fractions. I then simplified that diagonal, multiplied across, and I had my answer 10 and 1/2. Hope you found this helpful, and I'll see you next time. Bye.